All right, so in class, I gave you a bunch of notes on the transformations, and I have uploaded them to Google Classroom. Here they are for you. And so the hard part is definitely putting them all together. If we have a bunch of different transformations, being able to recognize them and putting them all together is the tricky part. So I wanted to do these examples for you to have to look at. So I want to take this step by step. So the first part is just state the parent function, right? So what is the original function if it was unchanged, right? And our options here are either I want to look for the quadratic, the cubic, the absolute value, or pretty much the square root. We also have linear, but we don't deal with that too often. So you just recognize the parent functions based on the symbols. So here in this first example, I have absolute value bars. So that is going to tell me that my parent function is the absolute value function. So that's step one. Then it asks me to identify the transformations, and there might be more than one. So I want to look for those vertical shifts, those horizontal shifts, or those reflections, right? So those are my options for the transformations. Some sort of vertical shift, horizontal shift, or reflection at this point. That's what we've learned, so that's what we're looking for, right? So look for vertical or horizontal shift. Running out of room. Or reflection. Now, from above, you should know the vertical shift is the outside change. So it's outside our parent function. Horizontal shift is inside. Reflection is a negative, either inside or outside. So if I look at this first function, this first example, I have a negative on the outside. So that is going to be a reflection, the negative on the outside. It's a reflection over the x-axis because the a value is negative. There's a negative out front, so it's going to reflect over the x-axis. And then the other transformation I have is an inside change. So that's got to be some form of horizontal. So it's going to be a horizontal shift to the, because it's plus, we're going to move to the left 3 units. Right, it's opposite when it's inside, so it's to the left 3 units. Then it asks for our domain and range. Well, for an absolute value function, the domain never changes. Any absolute value function, doesn't matter about the transformation, the domain is always negative infinity to infinity for absolute value. For the range, my advice would be to look at the graph. So if I go on to Desmos here, I type this function in, which is y equals negative absolute value x plus 3, this is what my graph looks like. And this graph is going, if I go bottom to top, that's how I read the range, is bottom to top. It stops at this point. That is the highest point. So the end point of my range is going to be negative, is going to be 0, right? The y value. The range is the y value. So my y value there is 0. So my range is going to stop at that 0 value. And since it is going down forever in both directions, it's going to come from negative infinity. Now let's take a look at the other function here. G of x, let's talk about the parent function. I physically see a square root, so that must be, right, look right here. Here's my square root symbol, so that must mean our parent function is the square root function. Right, so that's my parent function because I physically see that square root symbol. Now I've got to look for my transformations. There are two. The first one is a negative inside change. If it's a negative on the inside, it's affecting the x values and it's going to do the opposite. So this is going to be a reflection over the y-axis. I'm going to go from positive x's to negative x's, so I'm flipping over the y-axis. The other transformation comes from, again, this is an outside change, not an inside change. Notice how it's not underneath the square root. So it's going to be vertical. Since it's negative, it's going to be vertical down. So this is going to be a vertical shift down 2 units. Again, domain and range is easiest from a graph. Square root is the one that changes the most. So I'm going to pull up my Desmos here. There we go. Do my little side by side. I'm going to type in this function. So I'm going to have y equals, you could type g of x or y, doesn't matter, square root negative x, and then outside the square root I'm going to write minus 2. So I can see that my graph moved down and it's flipped. So my domain, right, it goes from left to right, so it stops at 0. The x values stop at 0. And if I keep going left forever, it's going to be negative infinity. So negative infinity to 0. And then I range bottom to top. The lowest y value here is negative 2. And as this goes left, it goes up. So to infinity. Annotate your work, guys. Look how much I have written here. Annotate. It helps. Mark it up. Write whatever notes you have to. So that's given the function identify everything. Now I can ask you, given the function identify everything and graph it. Graphing it is easiest when you have a table. So I'm going to start giving you tables when I ask you to graph things. So my parent function, again, I physically see the square root symbol here. So my parent function is square root. And then similar to the problem I just had, I have a negative on the inside. So this is going to tell me reflect over the y. And I have a plus 4 on the outside. So that's going to tell me to shift up 2. So this, my transformations I just said, reflect over the y-axis, which means multiply the x values by -1, and then we're going to shift up 4 units, which means add 4 to the y values. So those are my transformations. I'm going to graph it first, and it really helps to know the graph of the parent function. The parent function you should sort of just know. So this square root of x looks like this with these exact points. Right, so I've chosen the x values of 0, 1, 4, and 9 because those are perfect squares. And if I take the square root of each of those, this is what I get. So those are my points. Right, so my points are 0, 0, 1, 1, 4, 2, and 9, 3. So now to do my reflection over the y-axis, I'm going to multiply all of my x values by -1. So the first point doesn't change. If I multiply by -1 here, I get -1, 1, right? We're multiplying the x by -1. Here I'll get -4, 2, and -9, 3, right? I'm multiplying the x value by -1. So then I'm going to plot those. So -1, 1, -4, 2, and then -9, 3. And as you can see, this is a mirror image of the parent function reflected over the y-axis. But I'm not done, right? This would just be square root -x. So now I need to add 4 to all of my y values. So I'm going to do 0, 4, -1, 5, -4, 6, and -9, 7. Right, and on my graph I can just count up 4 spaces and plot my points. Because the x values don't change, I've already changed them. And this is what my final graph should look like for this whole transformation. All the transformations put together. So this is our g of x equals square root -x plus 4. And from that graph, I should be able to determine the domain and range, so I don't need Desmos here because I've graphed it on my own. The domain here, my smallest x value is right here. The x value is, the largest x value is 0. Right, we go left to right. This arrow here tells me that I go coming from -infinity. So -infinity to 0 for my domain. My range, here is my lowest point. This is the point 0, 4. So the lowest y value here is 4, and it continues to go up. So 4 to infinity. Notice how I didn't need Desmos there. I was able to just do everything on my own graph. And separate the transformations if you need to. Do one at a time. It's okay. Let's do another one. So here I have an outside change and an inside change. First things first, is this squared? Tells me that my parent function is a quadratic. If I graph my quadratic function here, my parent function, again, you should know the parent functions off the top of your head. Gotta go here and here. So this is my parent function. It's my U shape. That didn't come out so good. Let's try that again. Your graphs don't have to be absolutely perfect, as long as they're close enough. So then let's digest our transformations. Here I've got a negative on the outside. Negative on the outside means reflect over the x-axis. And then I have a +1 on the inside. This is going to shift left 1 unit because it's an inside change. Right? So those are my transformations. Reflect over the y-axis or the x-axis, excuse me. And shift left 1 unit. And the way I do that is by just doing it to my parent function. So I've already got my parent function graphed. I can write the points out and make the appropriate edits to the points. Right? So this means multiply the y values by -1. So my points for my parent function are 0, 0, -1, 1, 1, -1, 1, 1. Getting ahead of myself. We have 2, 4, and -2, 4. We have 3, 9, and -3, 9. So I want to multiply. I want to keep all of those x values the same, and I want to make all the y values negative. So I'm going to be here. 0, 0 doesn't change. -1, it's going to become -1, -1, 1, -1, -2, 4, sorry, -2, -4. Right, we're multiplying the y values by -1. 2, -4, 3, -9, -3, -9. Right, so basically, I'm just flipping everything here. It's going to be in the same spot, just on the other side of your x-axis. Right, so this is my reflection. But now I've got to move all of those points to the left 1 unit. So it's going to get kind of smushy in here. But the pink is just me moving each point to the left 1 space. So now the pink graph is the final graph with both transformations. So that's my g of x equals -x plus 1 squared. So that's my, like I said, that is my pink graph. of all my transformations, domain of every single quadratic is negative infinity to infinity. The range changes bottom to top. So bottom, since I have arrows going to negative infinity, we're going to be negative infinity to top. The topmost y value here is 0. So negative infinity to 0. So we've done 4 examples here when you're given the function to figure out everything from the given function. Now we're going to talk about if I give you the transformations, can you write the equation? So some of you weren't really writing you had problems like this on your homework and you weren't really writing the equation. I want you to actually write an equation that says like y equals with all of the transformations in it. So it should look, your goal is to get something that looks like this as your answer from what you're given. So when I look here, it tells me I'm automatically starting with the square root function. So I know I'm going to have y equals, I'm going to have a square root of something here. This tells me that I'm going to reflect over the y-axis. That means I'm going to make x negative. Right? Or multiply x by negative 1. Right? So that means I'm going to have negative x because I'm multiplying x by negative 1. This is an inside change. Then it says vertical shift up 7. Vertical shift means outside. And since I'm going up, I'm going to add 7. So outside my square root function, I'm going to do plus 7. And that is the final equation here. Y equals square root negative x plus 7 on the outside. Here I have a quadratic. So I'm going to have y equals x, and then I'm going to have a squared. But I want to see if there are any inside changes first before I deal with that. So let's kind of tackle this. Here I'm going to have a reflection over the x-axis. This is an outside change. So I'm going to multiply the y values by negative 1. Which means stick a negative on the outside here. Right? That's telling me that a equals negative 1. And a is on the outside. And then it says a horizontal shift left 8. This is an inside change. And then left 8 actually means plus 8, because remember, it's the opposite. So it's going to be inside. So I need parentheses, plus 8, close parentheses, and then I can add my squared back on. So I'm adding 8 directly to the x. And that is your final answer for that question. That is the equation given that description. You could also have f of x, but y equals is fine. The last one is a cubic. So again, y equals x cubed is the parent function here. So I know I'm going to have y equals, and I'm going to have an x. I know I'm going to have a cube somewhere, but I want to see, do I have any inside changes or not? So here it says horizontal shift right 2. There we go. That's my inside change. Since it's to the right, we're going to have minus 2 directly to the x values. So I'm going to do parentheses x minus 2, close my parentheses. Now I can put my cubed. And then this one says vertical shift down 4. This is my outside change. Minus 4. So minus 4 on the outside of my function. And that is the equation that matches those transformations. So we've taken care of graphing, writing the equation, understanding an equation, domain and range. Use this video to help you with your homework. If you're still confused after watching this video, please, please, please email me so that I can help you. Okay, the only way I'm going to know to help you is if you start speaking up before it's too late. If you have questions, as always, feel free to email me. Hopefully this helps. And that's transformations.